I'm walking around and they're really mushy. Lots of moisture. Anyway, goodbye. Don't get in your way there, buddy. You lead. And so that means the microbes are likely, see, look at this. Those are fresh mushrooms. As in, yep, not something we should be seeing in December and January. Anyway, that means these soils are nice and warm, and they've stayed nice and warm for a long period of time. There's no freezing. So the last winter that I hiked this trail, it was frozen. There's a shady side of the mountain that I'm on, and actually it's just in a ridge and valley that this particular loop stays shady. Lots of ice, lots of frozen waterfalls, none of which are frozen, no ice. So those microbes, that means their metabolism is warm, right? So they've sped up. That means their demand for sugar is going to be higher. And I would think, I don't know, soil biology is so damn complicated, right? So they've got all this carbon resource, some of them that they can get from this leaf material, which will probably decay faster. So if they get some of their carbon resource from that and some of it from the trees, maybe that helps maintain the mutualistic interactions instead of the trees being abandoned by the mutualistic benefactors or partners. Or does it mean that because the trees are going to use more of their own sugar to protect themselves from pathogenic fungi that are still active in these months when they shouldn't be, when they should be dormant, since they're not sharing their sugars with the microbes? And I mean, it's going to be different, right? Because the microbial community is so complex. Some are probably obligate with the trees, and they're just going to get screwed, and their population numbers will go down. And some of them are not obligate. It's called facultative, which means they can come and go in terms of that partnership. You know, like a fair-weathered friend kind of thing. The trees are often like that too. So it's not just one-sided. But then they can get more of the carbon resources from the leaves, provided there's sufficient leaf material of the sort and insect activity and arthropod activity to grind that leaf up so that the microbes can access it. Okay, but if that's the case, then isn't that going to be a negative feedback loop that leads to lower nutrition in the soils? Which, I mean, a lot of these plants are adapted to low nutrition, but not, I mean, some of these old trees, I'm guessing they need it pretty good. You can see I forgot to clean my camera lens. Apologies again. All right, so when there is high carbon intake from lots of leaf material, that can lead to all of the nitrogen that would otherwise be made available and moving through the soil micropore pool, or the soil pool of nutrients. You can think of it like a pool table where just all the balls are pulled together and they can go anywhere. That's a soil pool of nutrients, or a swimming pool. It's just, you know, they can go anywhere. All right, so that pool changes, and instead of it being full of nitrogen and phosphorus, now that nitrogen is being used by the microbe. Instead of them pooping it out, I'm being very cavalier here with my terms. Instead of pooping it out, they've got to use it because it costs so much in energy to break down that carbon. So they have less nitrogen to share with the plants, plant roots. Just thinking out loud, worrying out loud.